Hi guys, so today we're going to be looking at Chapter 5, Section 4, Solving Radical Equations and Inequalities. So the first example we have here is to solve the following. We have 3 root 2x minus 9, and this is subtracting by 1, and then this is supposed to equal to 2 in the end. So when I'm completing this, I'm going to start off first by isolating my root, or my radical. And so if I'm going to isolate my radical, then everything that's on the left side of my radical has to go away. So that means this negative 1 has to disappear. And the way that we can get rid of our negative 1 is by moving it to the other side by adding 1 to both the left and right side of the equation. If I do that, I'm left with the 3 root 2x minus 9 equaling to positive 3. Once I do that, then I can start focusing on the radical sign and getting rid of that. So the opposite of 3 root anything would be 2 cube on both sides. That would get rid of my 3 root, and I would end up being left with 2x minus 9 equaling to 3 to the power 3, which is 27. And then from here, you just end up solving for x. So I'll add 9 to both sides. That gives me 2x equaling to 36. Then I'm going to divide by 2 on both sides. And I'm left with x equaling to 18. And that would be my final answer. Okay. Oops. Try one more time. Okay, there it goes. All right, next problem. Next problem is going to be a word problem. It says in a hurricane, the mean sustained wind velocity v in meters per second can be modeled by the formula v of p equaling to 6.3 square root of 1013 minus p, where p is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So in the bottom here, when they're talking about how the wind velocity is 45.5 meters per second, they're talking about the v of p. They're talking about like the wind velocity, the solution. So over here, I'll just write down that v of p is supposed to equal to 54.5 in the end. And what we're trying to look for is specifically the air pressure, so our p value. And so when I do that, I'm going to have here v of p equaling to 6.3 square root of 1013 minus p, and I'm going to substitute my wind velocity for v of p. So I get here 54.5 equaling to 6.3 square root of 1013 minus p. And from here, all I'm going to do is solve for p. So to do that, I need to divide both sides by 6.3. When I divide 54.5 with 6.3, I get 8.65 to the power of 2, which ends up rounding up to 8.65. And then we get 1013 minus p. And I'm going to square root it on both sides. Sorry, I didn't mean to put that square root yet. So originally, this is what we get so far, just by dividing 54.5 divided by 6.3. And then to get rid of the square root, that's when I square it to both sides. And from there, I get left with 74 0.8, which is about 1013 minus p. Last thing to do is just solve for p again, so subtract 1013 to both sides. And that gives me negative 938.2 equaling to negative p. Then get rid of the negative 1 sign by dividing negative 1 to both sides. And that gives me left with 938.2, and that's around the amount of air pressure that we receive. So the air pressure is about 938.2 millibars. Done. Okay, let's try out the other problem. So let's say instead we have a different problem where we have x plus 1 equals to square root of 7x plus 15. It's going to be a little different because of the fact that originally we only had one number on the right side of our equation. This time we have two different terms, and so when I square root this and get rid of my square root, so we have here x plus 1 equaling to square root of 7x plus 15, and I square on both sides, I'm left with 7x plus 15, and on the other side again, because there's a plus sign, I can't just distribute the exponent. So from here, I need to multiply x plus 1 times x plus 1. That gives me x squared plus x plus 1, which is x squared plus 2x plus 1. So on the other side I have here x squared plus 2x plus 1. From that, since we have an x to the power 2, that means we have to use some form of factoring to solve our equation, which means that I need to move my right side to the left side. So I'm going to subtract 7x on both sides first, and I'll subtract 15 to both sides as well. And that way, I get left with x to the power 2 minus 5x minus 14, and that equals to 0. From there, I need to solve for x by using one of my factor methods. I'll use the box method, multiply x twice, and then on this side, I'll try out negative 7 times 2 and see if that works. If I cross multiply, I get 2x minus 7x, and that gives me negative 5x, which is what I wanted. So I know that my factors are going to be x minus 7 and x plus 2, and those are supposed to equal to 0. So I get x equaling to positive 7 and x equaling to negative 2 as my solutions. Now I can't just stop there. The problem is that we may possibly only have one solution instead of two solutions. So I have to check no matter what. This is the most important part that a lot of people end up messing up on. They do not check it, and they end up thinking that you have two answers, when in reality you might have only one. So always make sure to check. If I'm checking these, again, I'm substituting x for 7. When I substitute x for 7 into my original equation, I get 7 plus 1 equaling to square root of 7 times 7 plus 15. This becomes 8, and 7 times 7 plus 15, that equals to 64. And then square root of 64 is just 8. So this one ends up working, which is nice. Let's check out the second problem. Second problem, we have x is equal to negative 2. Then if I check it out, we have negative 2 plus 1 equals to square root of 7 times negative 2 plus 15. And then from here, we get negative 1 equaling to the square root of negative 14 plus 15, which is positive 1. So then I get left with negative 1 equaling to positive 1, which isn't true. So the only answer that I receive here in the end, so the solution, is not x equaling negative 2, but x equals to 7 only. That would be my only solution. So again, really important that you make sure to check after solving a problem that provides you with two different solutions. Let's try out one more problem. Let's say, for example, now you have a radical on both sides of the equation. And on top of that, you have a plus 1 on the outside. So if we have here square root of x plus 2 plus 1 equaling to the square root of 3 minus x. I need to get rid of the square roots because either way, if I were to move this to the other side, it doesn't really do much. In the end, I still have to just square root. So I'll square to both sides. When I square to both sides, I get left with, let's see, x plus 2 plus 1 times square root of x plus 2 plus 1. And that would equal to, let's see, this would turn into x plus 2 squared plus square root of x plus 2. And then, let's see, that multiplies with this multiplies with this, and then the 1 times square root of x plus 2 is just square root of x plus 2. And 1 times 1 gives you just 1. So I end up with, oops, don't forget the plus sign. I end up with x plus 2 plus 2 square root of x plus 2 plus 1. And I can combine the like terms 2 and 1 so that I get x plus 2 square root of x plus 2 plus 3. So that would be my left side here. That's the solution for the left side. On the other side, this ends up just being x minus 3 minus x in the end. Once I do that, I need to again move the 3, the x, and the 2 to the right side because we have just one more square root left over. So I'll move everything to the right side, subtract 3 to both sides, subtract x to both sides, and I get left with 2 square root of x plus 2 equaling to, this becomes 0, so that cancels out, and I get left with negative 2x. From there, I can divide on both sides by 2, and that will get rid of the 2 on the square root here. So it gets rid of this 2 at least. And we're left with square root of x plus 2. And that equals to negative x. Once I do that, I can finally get rid of this square root. So I'll square on both sides. And I'm left with x plus 2 equaling to x squared. And once I do that, again, got to move everything to the other side because of the square x to the power 2. We need to do some form of factoring. So subtract x and 2 to both sides. And from there, I'm left with 0 equaling to x to the power 2 minus x minus 2. And when I factor this out, multiply x twice, this try negative 2 times positive 1. Then that gives me x minus 2x, which is negative x. So I know I'm good to go. From there I get my factors, x minus 2 and x plus 1. And those are what I'm going to be solving for here. So next step is to find out my x values, which is 2. This becomes negative 1. And then after I do that, last thing to do is to check. So again, I need to check once. So need to see which ones work out in the end. We have here x equaling to 2, square root of 2 plus 2 plus 1 equals to square root of 3 minus 2. I get square root of 4 plus 1 equals to square root of 1. This is 2 plus 1 equals to 1, and this is definitely going to be false. 3 does not equal to 1. So I definitely can't use x equals to 2. Let's try out the other one, which is x equaling to negative 1. From here, square root, negative 1 plus 2 plus 1. And on the other side, I have 3 minus negative 1. This becomes square root of positive 1 plus 1 equaling to 3 plus 1, which is 4. Then we get 1 plus 1, that equals to 2, and this becomes square root of 4 is just 2. So this ends up working in the end. So I end up with just one solution, which is x equals to negative 1 is a solution. Done. Okay. So hopefully this helped. Good luck.